Hello and welcome to The Daily Space. I'm your host, Dr. Pamela Gay.
And I am your host, Beth Johnson.
And we are here to put science in your brain. As much as we enjoy studying the skies strictly for scientific reasons, sometimes it turns out there are less inspirational reasons, like making sure our planet doesn't get destroyed by incoming asteroids. Our solar system is filled with rocks, and while we'd like to think we found all the largest ones, the truth is, there are probably some space rocks capable of ending humanity still not discovered. And there are definitely objects big enough to destroy cities still missing from our catalogs. To fill in these gaps in our maps, a number of telescopes are regularly monitoring the sky. Here in the Northern Hemisphere, we are pretty full up on surveys. But in the Southern Hemisphere, there have been gaps in the coverage. Gaps a new telescope in Chile hopes to fill in. The European Southern Observatory and the European Space Agency have jointly completed construction of a new 56-centimeter telescope that is a twin to an existing telescope in Spain. Together, these scopes are testing new technologies that may be deployed in the future in a fly-eye telescope network designed to track fast-moving objects in the sky. These kinds of systems are particularly good at providing early warnings for incoming smaller bodies, like the meteor that struck in Botswana that we discussed last week, and the 2013 Chelyabinsk meteor event. Since the Earth's surface is mostly water, we don't actually know how common these kinds of events are. And I both dread and am excited by the prospect of these scopes discovering a lot of space rocks hitting Earth in harmless places.
Asteroids and fallen smaller meteorites are responsible for a lot of different things in our solar system. For instance, moon dust. Space rocks striking the surface of the moon have pulverized its surface into sharp dust that ranges in size down to nanoparticles, capable of irritating skin and damaging lungs. When not irritating astronauts, these tiny fragments are also responsible for giving the moon its colors and defining how much light it reflects. In a new journal article in IEEE Explore with first author Soman Badia, researchers discussed how they used tiny X-ray wavelengths of light to examine the shape of particles just 400 nanometers across. Several hundred of these particles could fit across the diameter of just one human hair. Just measuring these grains is remarkable. According to researcher Edgar Bogi, since they are so tiny and because they only come in powders, a single particle needs to be separated from all the others. They are too small to do that by hand, at least not in any quantity, so they must be carefully dispersed in a medium. The medium must also freeze their mechanical motion in order to be able to get a good X-ray CT image. If there is any movement of the particles during the several hours of the XCT scan, then the images will be badly blurred and generally not usable. The final form of the sample must also be compatible with getting the X-ray source and camera close to the sample while it rotates. So a narrow, straight cylinder is best. So basically, they made fancy moon dust popsicles, looked at them with X-rays, and got remarkable images of the dust grain shapes. Those shapes, depending on how round or elongated they are, give the moon its colors. This final what does each shape mean work is ongoing. Today, I just want to celebrate that they measured the shapes. And if you're imaging fancy high-tech setups, now we are celebrating the spirit of the tinkerer. According to the release, the procedure involves stirring the Apollo 11 material into epoxy, which was then dripped over the outside of a tiny straw to get a thin layer. Small pieces of this layer were then removed from the straw and mounted on dressmaker's pins, which were inserted into the XCT instrument.
As NASA plans to go back to the moon and eventually journey to Mars, a lot of energy is going into dust mitigation so that tiny, sharp dust stays away from humans. And they're also working to figure out how to build suits that allow astronauts to explore safely and easily. One of our big concerns with Mars is also radiation. And one of the ways to best escape radiation is to live and work inside a lava tube. To this end, researchers have donned spacesuits to explore Hawaiian lava tubes to figure out what is and isn't possible and what problems need to be solved. This research is being presented at the European Geological Assembly's meeting this week by Bernard Foyng. According to co-researcher Michela Maselava, doing research in suits under EVA constraints makes everything much more difficult to do, and it all takes 3 times longer. We need to train extensively on Earth to figure out the best methods and create the best EVA suits so that we'll be able to perform this kind of research on the moon and Mars one day. This is your reminder that for every great accomplishment off the Earth, there has been countless hours of development, testing, and training here on Earth, both in giant pools and in high desert environments, testing and training that's done by folks whose names are rarely mentioned and whose faces, well, those are hidden in these amazing helmets. After the break, we'll be back to discuss something I didn't think could exist: antimatter stars. Hang on, things are about to get a little weird. So, when you study astronomy, and people learn that you study astronomy, you get asked lots of questions along the lines of, could there be antimatter stars? Could there be antimatter galaxies? Could there be dark matter galaxies? And while we think we have found galaxies made out of dark matter, I think most of my colleagues have gone through life saying, no, there are not antimatter stars. And we might be wrong. And this is why we do science. We want to figure out what is real about the universe. And we recognize we don't actually know everything. We are just trying really hard to know everything. Now, there are 2 kinds of matter. And we're really bad at naming things. There's the stuff we're made out of: electrons, neutrons, protons, regular matter. But all of these particles have an antimatter version. Neutrinos have an antimatter version. And if you've watched Star Trek, you know that controlled reactions with antimatter generate a ton of energy. Now, this is because if you put a regular electron and its antimatter cohort, a positron or anti-electron, together, they're going to combine into energy. It's awesome, and luckily doesn't happen all the time. For the most part, when particles come together, the reactions aren't right to release energy. Antimatter neutrinos are passing through you constantly. No big deal. But for reasons we don't know, our universe probably formed with equal amounts of matter and the opposite charge, otherwise identical, has gravity working in the same way, has mass working in the same way. It's just that charge that's different. The universe probably formed with equal amounts of matter and antimatter, and then something went sideways, and we got left with a universe that is pretty much all matter. And we thought that meant no antimatter stars. But a group of astronomers has gone through the Fermi Gamma Ray Telescope's data and discovered 14 different flickering spots in the sky that give off flashes of gamma ray light that are consistent with those 14 sources being antimatter stars. How this happens, no idea. Is this what actually happened? No idea. This is one of those times where you look at something, there are a variety of options, and one of them defies all expectations. So those 14 flickers are consistent with antimatter stars. That means somehow our universe had clumps of antimatter that survived in the midst of all the matter or managed to form later. Those clumps of antimatter collapsed down into stars. And because matter and antimatter look identical in how they do fission and fusion and all those sorts of things, those stars would be shining just like any other star, except when a bit of actual matter hits them just right, gamma rays happen. Gamma rays, people. Now, normally I would simply look at this research and go, that's cool, don't believe it, and set it aside. The reason I didn't entirely do that today is because an experiment aboard the International Space Station captured evidence of random antimatter helium, just kind of hanging out, existing as helium atoms do, except it was antimatter helium, folks, antimatter helium. And the best way to explain that is if there's antimatter stars. Again, this could have an entirely different explanation. We do science to figure these things out, but the universe just keeps showing us it's more creative than we are in coming up with theories. And so we have two lines of evidence: random antimatter helium detected by the International Space Station experiment, and 4 sources of flickering light. Now, if there are antimatter stars out there, they probably aren't common, or we'd see a whole lot more flickering. Based on the density of the kind of material that's hanging around and would be hitting these antimatter stars, if they exist in the disk of our Milky Way, which we'll talk about more in a later segment, if they exist in the disk of our Milky Way, they'd only be 1 in every 400,000 stars, because there's so much stuff floating around that would be hitting them that they'd be twinkling like Christmas lights, but in gamma rays. If, however, they're super rare and they only exist in the outskirts, the halo of the galaxy, there could be as many as 1 in 10 stars out there that are antimatter, and we just don't see them because there's not a lot of stuff hitting them, causing them to flicker. Again, I'm not saying we found them. I'm saying there's some cool stuff going on we don't understand. And one really weird explanation that I would never have expected to see is that there's antimatter stars. This work is published in Physics Review D by Simone Dupoquet, Luigi Tebaldo, and Peter von Balnos. We're going to follow this story, folks. I don't know where it's going to go, but that's going to happen on another day. For now, we're going to go to break, and when we come back, we're going to be talking about chemistry out there on other worlds. Stay tuned.
It seems astronomers are always searching for something new, something special, something groundbreaking that will lead us on to the next big discovery. And while anti-stars are incredibly fascinating, and I hope we discover them, I'll be over here watching as our ability to detect certain particles in the atmospheres of exoplanets continues to grow. In a recent paper in the Astrophysical Journal Letters, an international team of astronomers reports on finding hydroxyl, that tiny molecule consisting of 1 hydrogen atom and 1 oxygen atom, in the atmosphere of superhot Jupiter WASP 33b. Now, when I say super hot, I mean that because this planet orbits its star at a distance closer than that of Mercury to our own sun, atmospheric temps reach more than 2,500 degrees Celsius. That's hot enough to melt most metals, y'all. Finding hydroxyl on a hot Jupiter isn't just exciting for the discovery itself, but also for the upgrade in technology that allowed the team to make the discovery. A new instrument at the Subaru telescope in Hawaii called the infrared Doppler uses absorption spectroscopy, dark lines breaking up a full rainbow of light, to detect the fingerprint of various molecules. The instrument works by using the Doppler shift of the light as the planet's velocity changes relative to Earth while it orbits its host star. Basically, we can use those changes in velocity to separate the planet's characteristics from the stars, since the star's velocity doesn't change, again, relative to Earth. And then we match the dark lines with the known patterns of a variety of atoms and molecules to figure out what is in the atmosphere. Hydroxyl is an important molecule to find. Here on Earth, it's produced by the reaction of water vapor with atomic oxygen and is considered an atmospheric detergent because it reacts with polluting gas like methane and carbon dioxide to essentially remove them. In the case of WASP-33b, though, the hydroxyl is produced by the destruction of the water vapor under the high heat of the star. And confirming the likelihood of this explanation is the very weak signal of water vapor in the data. But why bother with hot Jupiters? As co-author Dr. Neil Gibson states, the science of extrasolar planets is relatively new, and a key goal of modern astronomy is to explore these planets' atmospheres in detail and eventually to search for Earth-like exoplanets, planets like our own. Every new atmospheric species discovered further improves our understanding of exoplanets and the techniques required to study their atmospheres and takes us closer to this goal. And co-author Chris Watson adds, while WASP-33b may be a giant planet, these observations are the test bed for the next generation facilities like the 30-meter telescope and the European Extremely Large Telescope in searching for biosignatures on smaller and potentially rocky worlds, which might provide hints to one of the oldest questions of mankind: are we alone? We'll be back in a moment to round out our show with this week's What's Up segment.
Tis the season for galaxy observing, or at least for observing our galaxy from edge to core as the world rotates. If you live in a particularly dark area, you can go outside right now after, well, twilight has totally ended and watch the brightening glow of our disk of stars and dust and gas begin to light up in the sky. Now, early in the evening, what you're going to see is looking out away from the center of the Milky Way. So you're looking out through the disk, bulge behind you, out to the universe beyond. Now, the thing is that as you look at that Milky Way, it doesn't really appear any different when you're looking straight out and when you're looking at a right angle through the disk. In fact, throughout the night, as the sky rotates, it's not until you get towards dawn and the rise of the constellation Sagittarius that you're gonna start seeing things change dramatically with the rising of the bulge. This lack of difference made it really hard for early astronomers to figure out where we are in the Milky Way, because the dust and the gas just obscure stuff. And we know which direction the center of the galaxy is in only because it gets thicker there, and we can see that. In order to figure out where we are, astronomers actually had to look out of the disk at those faint fuzzy objects called globular clusters. We know they form roughly a spherical population around our galaxy. And so by measuring the distribution of them, assuming that they're in a sphere, we were able to figure out we're a fair ways away from the center and the disk. So right now, good time to get out and look up. Now, if you're in the southern hemisphere, you get to see some amazing things we don't get to see up here in the north. Specifically, you get to see the large and small Magellanic Clouds, which kind of look like someone took a handful of the disk of the Milky Way and just cast it off sideways, splatting two splatters of stars. Now, throughout my career, I've seen people discuss, are these or aren't these going to merge into our galaxy and become a new part of the Milky Way? And the answer, it turns out, is it's up to dark matter. We just don't know. But we're getting closer to finding out. There's a new paper in the journal Nature, and researchers are discussing imaging campaigns led by Charlie Conroy that studied the effects of the Large Magellanic Cloud on our galaxy's halo as it passed through. It has long been thought that this small galaxy and its visible matter and dark matter should leave a wake in our galaxy's visible and dark matter. So you have galaxy of stuff passing through our galaxy's outer distribution of stuff. To back out and take a look at exactly what is going on, we have our galaxy, the spheroid around it, and then the large and small Magellanic Clouds racing through that spheroid of material. Well, we assumed that just like a boat racing through liquid, these galaxies would leave a wake. We hadn't seen it before. This is the first time we've been able to make out how the Large Magellanic Cloud disturbs the Milky Way's dark matter. And it's going to allow us to start understanding some new properties of the dark matter. Think of it this way. The wake of a boat varies depending on if the boat sails in water or glycerin, the stuff they use to make your shampoo the consistency it is. Folks, if you don't know what this looks like, this is an experiment we did with undergrads when I used to teach. You can take toy boats and sail them in water and glycerin, and it does not work the same way in both cases. Now, with our researchers, here's how they're explaining it. It's a really special set of circumstances that came together to create this scenario that lets us test our dark matter theories. This is a quote from Gurentina Besla, a co-author of this study. I can't wait to see what they learn from this wake they have discovered. Science can be beautiful, amazing, and slow. These stories will be discussed more in future episodes as this research advances. For now, this has been the Daily Space.
You can find more information on all of our stories, including images, at dailyspace.org. As always, we're here thanks to the generous donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
Broadcasting live from Houston, the space capital of the world, this is NowMedia TV. Television for business leaders.
COVID-19 transformed the way we do business. Now more than ever, fast lead generation and customer retention will determine if a business survives or not. The NowMedia Video Business Card is designed to be sent using your smartphone. It's the next generation business card that will open the door for you while keeping social distancing. The NowMedia Video Business Card is affordable for anyone from startups to multinational companies and is already being used by hundreds of businesses. Stay open, stay in business. Call us today.
Shopping for health insurance on your own can be difficult and overwhelming. The market is saturated with confusing lingo and thousands of plans. It's hard to know what is best for you, your loved ones, or your employees. I'm Derek Tice, your personal guide to the health insurance industry. I'm licensed in over 30 states, and with year-round open enrollment, there's no need to wait to get started. You can choose from nationwide PPO network plans so that you have access to any doctor or hospital. I can research supplemental needs, including dental, vision, short-term disability, and life insurance as well. Small business owners can also get coverage on or off the job to prevent workman's compensation claims. Together, we can build a plan that will protect your health and your financial future. Call, click, or text today at 936-672-5507 to set up your one-on-one consultation today. At Tice Health and Life, we protect your wealth by ensuring your health.
Hello and welcome to the Daily Space. I am your host, Dr. Pamela Gay.
And I am your host, Beth Johnson.
And we are here to put science in your brain.
There are a lot of blink and you missed it things that are hard to see here on Earth. From the sight of a particularly bright meteor during a star party, the acrobatics of a dolphin leaping out of the water on a ferry trip, if you are looking the wrong way and at the wrong moment, you miss everything. In looking at the sky, what it means for something to be short-lived is a little different, but the idea is the same. As we scan across the sky, we see lots of fully formed stars, which can live for billions of years. We see a fair number of things that last hundreds of millions of years. But the shorter lived the phenomena, the harder they are to find examples of in the sky. Catching planets in the process of forming is one of those short-lived phenomenons that we're struggling to catch. This is a double problem. We have to catch something short-lived, and we have to catch it with just the right geometry that we can see the planet separately from the star. Of the 4,000 exoplanets of all ages so far found, only 15 have been directly imaged by a telescope as a dot beside a star. Now, with a combination of hard work and a bit of luck, a still-forming planet has been imaged orbiting an orange dwarf star, PDS 70, just 370 light years from Earth. A mere hop away. This is one of 3 planets in this system, and according to lead researcher Yifan Zhao, this is the youngest bona fide planet Hubble has ever directly imaged. Zhao developed novel data processing techniques that allow the research team to carefully separate the light from the star and the planet, allowing them to determine the planet is continuing to slowly grow as it circles at a Uranus-like distance from its star. Now we just need to find a whole bunch more of these at different ages so we can measure growth rates at a variety of different times. This work is published in the Astronomical Journal.
Like Beth said, short-lived means a lot of different things in the context of the universe. Planet formation goes on for millions of years, and the effects of phenomena like solar flares might last for only hours or maybe minutes or seconds. Researchers studying Mars using radars on both the Mars Express and Mars Reconnaissance Orbiter have periodically experienced weird blackouts in their data where radar returns stop returning. Since studying these weird blackouts wasn't the goal of taking radar data, understanding what is causing this has been a back burner problem that may finally be understood. In research led by Mark Lester and including some of our Planetary Science Institute researchers, Than Putzig and Matthew Perry, it has been determined that solar energetic particles can ionize the lower atmosphere on Mars, and this partial ionization prevents healthy radar returns. Basically, an active sun means no radar for science from the Charade and Marsis radar instruments or for their scientists. While this is no big deal, the research can be done at different times. It is problematic if the radar can't get through. This also means that communications with future robots and humans also won't be able to get through and will be disrupted periodically by solar activity. And this is just one more problem that will need to be sorted if we want to keep humans safe on Mars.
The words short and rare really are a matter of context. Female PhD astronomers, hi Pamela, they're rare, but we see them. Humans were short-lived, but we see them. Still there, Pamela? When it comes to the shortest-lived and rarest events, I have to say the moment that a bunch of molecules become a living cell, that may be one of the rarest and shortest-lived things we really wish we understood. While I doubt we'll ever catch life naturally coming into existence that way, we'd like to figure out how to force this to happen in a lab. And doing a lab experiment like this requires researchers to understand where the stuff of life actually came from. In new research published in Science Advances and led by Yoshihiro Furukawa, researchers announced that the organic chemistry necessary to create the amino acids that build life could have used wildly available materials found in the early solar system. This work required the team to study the compositions of meteorites that contained essentially locked samples of the building blocks of planets. This allowed them to see what kinds of reactions took place and hint at what reactions, foremost type reactions if you want to know, might have led to, well, us. After the break, we're going to switch from things that create life to things that are a bit more dangerous. Tsunamis. Stay tuned. As a planetary geologist, I'm more well-versed in ways of destroying life than in creating it. This next story is your daily reminder that the universe is trying to kill us, and it doesn't even need rocks from outer space to do so. No, the universe can rely on Mother Earth to do her fair share. When I taught a natural hazards class, one of the things I had to explain to my students were the hazards that go along with earthquakes. After all, I live in earthquake country, but beyond the normal shaking and rolling land waves we get here in California, there is one type of hazard our quakes aren't generally responsible for: tsunami. These deadly events are usually the result of subduction earthquakes, those ones where one tectonic plate is going under another plate. Subduction earthquakes are common around the Pacific Ocean in what is known as the Ring of Fire. The same plate interactions that cause those volcanic arcs we talked about a couple of weeks ago also come along with massive quakes. And when one of those happens, the upward thrust of the topmost plate causes water to be displaced upward. That water has to go somewhere to keep everything even. And like ripples in a pond, it spreads out from that point of origin, creating a tsunami. As the tsunami approaches the shoreline, the water pulls back from the shore while the wave front gets compressed in the shallower depths, building up what we think of as a wall of water. In the 2011 Tohoku earthquake, the wave height at the shore was on the order of 10 meters, causing massive amounts of destruction along the coast and even farther inland. The water will keep moving, and because these huge ripples bounce, they'll go back and forth for a while. The 2004 Boxing Day tsunami occurred as a result of a quake off the coast of Sumatra, and over 200,000 people died as a result in countries as far away from the epicenter as Kenya and Tanzania. Unfortunately, we tend to learn lessons only when they are particularly harsh, and scientists realized that this extreme death toll was partially due to the lack of warning systems in place in the region in 2004. So they quickly increased the number of deep ocean assessment and reporting of tsunamis, or DART, buoys in the region, and created a network that now includes over 60 of the floating sensors. This also includes 12 new buoys over the Kermadec Trench near New Zealand, which is a particularly fast-moving subduction zone and prone to frequent high-magnitude earthquakes. And they got to witness, in the resulting data this year, an extremely rare event, a triple tsunami as a result of 3 closely spaced, very large earthquakes, all over magnitude 7. These earthquakes occurred on March 5th, 2021, off the coast of New Zealand, all within 1,000 kilometers of each other and several hours of each other. Each quake spawned its own tsunami, and the buoys recorded the changes in wave heights as each event passed by. Since the data is analyzed in real time, local authorities were able to keep the public informed of any pending threats and to cancel the warnings when the threat had passed. Because the buoys are in place, authorities canceled the alert more than 4 hours earlier than previously possible. And these buoys don't just save lives and time in the South Pacific. The tsunami generated by all these subduction earthquakes can travel swiftly across the Pacific and Indian Oceans at speeds in excess of 800 kilometers per hour. And they can reach distant shores in countries like Chile and the United States. During that 2011 quake, several lives were lost in California, and the property damage in marinas along the coast was extensive. So here's hoping for more buoys in more places to save more lives. Coming up next, Pamela will go back to beginnings and talk about the reionization of the universe. Stay tuned.
From Earth destruction, let's jump to universe construction. A recurring theme is, how did everything start? Like, we know there was a Big Bang, things expanded and cooled for 400,000 years, and then stars and galaxies started doing their thing, and their light cleared out the universe. Where we get stuck is, did those galaxies most responsible for clearing out the universe grow from massive collapse of stuff into massive galaxies, or through the formation of a myriad of tiny galaxies? We know galaxies formed both ways. The universe is all about yes and. But in this particular whodunit, we're learning that while there was massive galaxies out there clearing out their surrounding gas and ionizing everything with ultraviolet starlight, it may have actually been the small galaxies scattered everywhere that actually did the bulk of the work. Researchers led by Nathan Egan and publishing in the Astrophysical Journal show that one tiny galaxy is clearly doing a lot to blow out the universe. This galaxy is Pox 186. It's a compact system with about 100,000 solar masses of massive stars. Where it's located just a couple billion years after the formation of the universe, its light is ionizing the neutral gas all around it. And part of how it's doing this isn't just the ultraviolet light, it's actually the stars as they explode as supernovae are pushing out the gas. Their ultraviolet light is breaking free of the galaxy, and all around this galaxy, the universe is becoming transparent. Now, little galaxies like this were the most common. And just like a single bonfire will do a really good job lighting up one part of a field, if you fill that field with 100 campfires, you can light so much more. And it looks like these little galaxies, like Pox 186, they lit not just so much more, but everything. And because of them, we can look back to the earliest moments of the visibly transparent part of the universe a few billion years after it started. And once the JWST maybe launches, we're going to go with maybe, because superstition at this point. It will be able to see just what was forming. After the break, we're going to be back to talk about what is time anyways. Trying to understand the timescales that things happen in our universe is something our little human brains sometimes struggle with. From the formation taking moments to go from nothing to all the energy and matter that ever is and ever will be, to 400,000 years before we actually start to be able to see anything, to millions and billions of years for that gas to form the first stars. Time, it's vast and sometimes seems to stop. In fact, there are days right now where I have to ask, what is time anyway? This morning, as I worked on this show, I looked around my office and realized it is fossilized to January 2020. Calendar on the wall still says December 2019. Yearly passes attached to lanyards on the bulletin board, 2019-2020 year. Everything just kind of stopped as every day became Blur's Day. As humans, we don't see millions and billions of years. We measure the passage of, well, depends on the human, just what you say. Today, to many people, is measured from the moment of waking to the moment of sleeping and then waking up the next day. Even if that today happens to span multiple calendar days. A year for a teacher or professor is September to August. Time. How we divide it up, at least, is just an arbitrary set of decisions. For the purposes of science, a day is the amount of time it takes for a single point on a world to go from noon to noon, except when it isn't. Here on Earth, we rotate such that the sun moves across our sky daily for folks not at the poles, and we have a close to 24-hour day. For Uranus, the planet is flipped sideways, so the solar day and the orbital period are the same, 84 Earth years. But relative to the stars, a day would be measured in Earth hours. Of course, exactly how you measure that rotation of a gas planet is a bit hard. What do you measure the rotation against? With Saturn, folks have decided to measure a day based on the ripples the planet's rotation causes in the rings. By the way, Saturn's day, it's 10 Earth hours and 33 minutes long. Gas planets, they're just kind of hard to sort.
Filed under why is this so hard, it turns out that cloud-covered solid planets can actually hide the length of their day pretty effectively too. While Venus is in many ways a twin to Earth, similar size, similar original composition, the world had a rather catastrophic history that isn't explained by just its closer distance to the sun. Understanding what happened actually requires understanding how Venus rotates and how that reflects its internal structure. The thing is, we can't see its surface. While orbiting satellites can get some information on its day length from radar images, their fast orbits and the influence of Venus's shape on their orbits make precision hard. In fact, past measurements didn't match each other. So scientists started hitting Venus with radar from Earth, and over long periods found, quote, the new radar measurements show that an average day on Venus lasts 243.0226 Earth days, roughly 2/3 of an Earth year. What's more, the rotation rate of Venus is always changing. A value measured at one time will be a bit larger or smaller than a previous value. The team estimated the length of a day from each of the individual measurements, and they observed differences of at least 20 minutes, unquote. When your average day is 243 Earth days, a variation of 20 minutes actually isn't a lot. But how Venus got that way, that is a serious mystery we can't solve today.
Well, we can't solve everything. We can still celebrate what we can solve and what we can see and what it inspires us to create. And we here at Cosmo Quest know that many of us are still trapped in our houses, and we just generally need something to bring us joy. And this July, we are going to bring you Cosmo Questicon, a virtual event that is going to celebrate the discoveries of the 1980s with all its neon-colored acid wash gene glory. From the space shuttle to the Voyager missions to everything in between. We're gonna rock like it's the 1980s. Not quite as cool as saying 1999, but still, Purple Rain, it came out in the 1980s. Come celebrate with us. You can get your tickets now. We're going to be doing the main stage events free to all on Twitch, and there is going to be a second stage and a backstage lounge where you can meet guests, all available through Discord, all virtual to keep everyone safe. Check it out, cosmoquest.org.
As a reminder, we celebrate May the 4th around here. It's a somewhat silly holiday, but we are all geeks and nerds, and so we get a little silly with it. In this case, May the 4th is a play on Star Wars. May the Force be with you. And since about the 80s, speaking of, people have kind of acknowledged this as sort of an unofficial Star Wars event. And now it's sort of an official Star Wars holiday. And around here, we count it as a work holiday. So there won't be any shows from us that day. But if you're interested, I will be doing some other things over at the SETI Institute. And you can check all of that out at SETI.org. So join us again next week when we come back.
For now, this has been The Daily Space.
You can find more information on all of our stories, including images, at dailyspace.org. As always, we're here thanks to the generous contributions of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.
My name is Barbara, and I'm the owner of Blades Appraisals and Art Resources. I appraise fine art, antiques, collectibles, and residential contents. My projects have ranged from an autographed Hall of Fame baseball bat to an entire museum's art collection. Here's when you should call me. The top 4 reasons. Number 1, advance estate planning to minimize your family's tax bite, as well as ensure an equitable settlement between parties after death. 2, I understand the IRS guidelines for donations. I can make sure you get the maximum value for your donation. 3, making sure you have adequate and appropriate insurance coverage. And 4, when you decide to downsize and you want to sell part of your collection, I will help you maximize the value by recommending the appropriate method of sale. Feel free to reach out for a complimentary project estimate. If I can't help you, I will make a recommendation. I truly enjoy my work, and I'd love to hear from you.
As a critical aspect of your operations, you need the right technology partner to provide you and your business the peace of mind of having reliable and efficient IT systems. In addition, with cyber threats, ransomware at an all-time high, adequate, continuous, and proactive data protection for your business is an absolute must. Hi, this is Roland Parker with Impress Computer Solutions. We are experts in tailored IT solutions and professional 24/7 IT support services. We proactively monitor, maintain, manage, and protect your IT and data assets. Additionally, we have the know-how and horsepower to do the correct procuring of any and all computer systems or software your company may need. Having the correct IT infrastructure and not being able to operate safely and correctly is very expensive and can eventually destroy growth. So take a decisive step and call me today for a complimentary consultation at 281-647-9977 for your unique IT needs.
COVID-19 transformed the way we do business. Now more than ever, fast lead generation and customer retention will determine if a business survives or not. The NowMedia video business card is designed to be sent using your smartphone. It's the next generation business card that will open the door for you while keeping social distancing. The NowMedia video business card is affordable for anyone from startups to multinational companies and is already being used by hundreds of businesses. Stay open, stay in business. Call us today.
I'm here to take you to a new frontier, the final frontier. In fact, you and I are going where no one has gone before. I'm Glenn Henderson, entrepreneur, success coach, and musician, and I want to personally invite you to take this journey with me in the pages of my best-selling new book, All I Need to Know About Success I Learned from Star Trek. We'll travel aboard the USS Enterprise along with Captain James T. Kirk, Spock, and the finest crew in Starfleet. And we'll learn together about success principles like how to work with a team and accomplish your goals, when to fight for what you believe, and when not to, and what your business really is. no matter what you do for a living. Beam aboard with me. My mission is your success, and I'll see you on the bridge. Live long and prosper.
My name is Brooks Boyd, and I'm the owner of Senior Savings Organization, a Medicare insurance agency. Medicare is confusing, it is not a one-size-fits-all plan, and I help folks navigate the maze. My main job is to educate so you pick the approach that feels right and make sure you avoid costly Medicare mistakes. I will help with transitioning from group health to Medicare with a personalized report to see if it makes sense to either stay on your current insurance or to consider enrolling into Medicare with either a supplement or a Medicare Advantage plan. And I'll explain the difference between the two and the pros and cons of each. If you need help with Social Security planning, I can show you how to maximize your benefits with a free Social Security maximization report to make sure that you are confident that you will get the most out of your Social Security benefits. I am an independent broker. This is a no-cost consultation, and you will never pay a fee with me.
Hello, I'm Pamela O'Brien, owner and principal designer at Pamela Hope Designs. We're an award-winning full-service interior design firm located in Houston, Texas, with clients nationwide. We specialize in medium-high to high-end residential and commercial design projects that inspire confidence in you. When asked about our design style, we believe our style is your style at its best, while respecting your budget, your preferences, and your lifestyle. Our talented team of designers, artisans, and craftsmen collaborates with you to create positive design experiences with exquisite results. Unveiling exceptional designs is a privilege, and we want to make it a pleasure for all involved. From updating your existing home or office for a fresh new look to creating a custom project from the ground up, everything we do is designed for you.
Broadcasting live from Houston, the space capital of the world, this is NowMedia TV. Television for business leaders.
Los negocios modernos buscan constantemente reducir sus costos de personal, especialmente cuando inician. Además, asistentes personalizados, preparados y profesionales son fundamentales para las buenas relaciones con los clientes y proveedores, ayudando a los dueños de negocios sin importar el tamaño al estar organizados y trabajar de una manera eficiente. En BetaWorld Business Centers hemos creado un servicio que está cambiando la forma en que los pequeños y medianos empresarios trabajan y lo llamamos BetaWorld Virtual Assistant Service. Un servicio que provee un asistente en los Estados Unidos, entrenada, bilingüe y profesional para el manejo de su agenda, ejecución de tareas, coordinación de clientes, proveedores, manejos de llamadas, mensajes y correos, coordinación logística y de viaje, así como cualquier actividad que apoye al pequeño o mediano empresario a enfocarse en su negocio. Todo a una fracción del costo de un asistente de tiempo completo y con disponibilidad durante sus horas de oficina. Llámenos al 281-944-9116 y permítanos ser parte de su éxito.
Do you know people will treat you based on your looks? Are you tired of living a life with dietary restriction? Do you feel guilty every time you eat? Revenge can be sweet, especially if you don't gain weight. Hi, this is Karelis with Clean Meal. I love to eat delicious food and desserts without the guilt. Do you have diabetes? Do you have gluten allergies? Or maybe you are lactose intolerant? Clean Meals bring to your home incredible desserts with the best ingredients: sugar, gluten, and lactose-free, organic, and keto-friendly. Recover that energy that you long for. Fall in love with yourself and eat with no guilt. Clean Meal. delicious and healthy, because you become what you eat. Sabes que como te ven te tratan. Llevas una vida llena de restricciones. Quieres comer delicioso y sin culpas. La venganza es dulce, sobre todo si no te engorda. Hola, te habla Kareli Zurrutia de Clean Meal. Me encanta comer delicioso y sobre todo sin culpas. ¿Sufres de diabetes? ¿Eres alérgico al gluten o intolerante a la lactosa? ¿Eres amante a los dulces? Clean Meal lleva a tu casa los postres más ricos y saludables que te puedas imaginar, con los mejores ingredientes, libres de azúcar, de gluten y lactosa, orgánicos y 100% natural, que además están aprobados en la dieta keto. Llénate de energía, enamórate de ti y come sin culpas. Clean Meal, rico y saludable, porque te conviertes en lo que comes.
Are you tired of calling several different moving companies and still wondering if your moving needs will be met with a company that is committed to the satisfaction of their clients? Can you really trust a random moving company you just looked up online? Hi, my name is Daudakan. I am Mr. President with Yo Move Moving and Storage. We are the experts in moving and storage business with over 15 years of moving experience. We know how to safely and easily take you from your current home or office to your new home and eliminate the stress of packing, shipping, delivery, storing, and moving to your new home. Additionally, at Your Move, we make sure our bids are complete with no hidden charges and fully explain every step of the moving process. Our job is to move you with ease and safety. Whether you're moving across the street or across state lines, Your Move will get you there. Give us a call at 281-988-9700.
I'm here to take you to a new frontier, the final frontier. In fact, you and I are going where no one has gone before. I'm Glenn Henderson, entrepreneur, success coach, and musician, and I want to personally invite you to take this journey with me in the pages of my best-selling new book, All I Need to Know About Success I Learned from Star Trek. We'll travel aboard the USS Enterprise along with Captain James T. Kirk, Spock, and the finest crew in Starfleet. And we'll learn together about success principles like how to work with a team and accomplish your goals, when to fight for what you believe, and when not to, and what your business really is.